Table 300.5 of the National Electrical Code, also known as NEC, specifies minimum cover requirements for electrical raceways under driveways, parking lots, and similar locations. For non-metallic raceways, the minimum cover depth is 24 inches. Exception number 2 to Table 300.50 applies to raceways operating above 600 volts and permits a reduction in cover depth for every 2 inches of concrete protection. However, it's important to note that this particular exception does not directly apply to 480 volts feeders. The National Electrical Contractors Association, or NECA, recommends a minimum cover of 24 inches for 480 volts feeders encased in concrete under driveways or parking lots. This recommendation is firmly grounded in industry best practices and extensive field experience. To summarize, based on the available information, the appropriate burial depth requirement for 480 volts feeders in concrete encased polyvinyl chloride, also known as PVC, conduit under a driveway or parking lot should be 24 inches. This recommendation aligns with both the National Electrical Code requirements and established industry standards. It's crucial to adhere to these guidelines to ensure electrical safety and prevent potential damage to the electrical system. When installing electrical conduit under driveways or parking lots, several factors must be taken into account to ensure safety and compliance with electrical codes. These factors include the type of raceway, the voltage level, the type of encasement, and the potential for physical damage. Firstly, the type of raceway plays a significant role in determining the required burial depth. Non-metallic raceways, such as polyvinyl chloride conduit, typically require a greater burial depth compared to metallic raceways due to their lower resistance to physical damage. Secondly, the voltage level of the electrical conductors within the raceway also affects the burial depth requirement. Higher voltage systems generally require deeper burial depths to provide adequate protection against electrical hazards. Thirdly, the type of encasement used to protect the raceway can influence the required burial depth. Concrete encasement provides additional physical protection and may allow for a reduction in burial depth in some cases, as specified in the National Electrical Code. Finally, the potential for physical damage to the raceway is a critical consideration when determining the burial depth. Driveways and parking lots are subject to heavy traffic and potential impact from vehicles, so adequate burial depth is essential to prevent damage to the electrical system. Table 300.5 of the National Electrical Code provides specific requirements for the minimum cover depth of underground electrical raceways based on the voltage level and the type of raceway. For non-metallic raceways, such as polyvinyl chloride conduit, the minimum cover depth under driveways and parking lots is typically 24 inches. However, there are exceptions to this rule, such as when the raceway is encased in concrete. When a raceway is encased in concrete, the National Electrical Code allows for a reduction in the required burial depth, provided that the concrete encasement meets certain specifications. The amount of reduction in burial depth depends on the thickness of the concrete encasement and the voltage level of the electrical conductors within the raceway. In the case of 480 volts feeders encased in concrete, the National Electrical Code does not provide a specific exception for reducing the burial depth below 24 inches. Therefore, the recommended burial depth for 480 volts feeders in concrete encased polyvinyl chloride conduit under a driveway or parking lot remains at 24 inches. It's important to note that the National Electrical Code is a minimum standard and that local codes or regulations may require a greater burial depth. Therefore, it's always advisable to consult with a qualified electrical engineer or inspector to determine the specific requirements for a particular installation. In addition to the National Electrical Code requirements, industry standards and best practices also recommend a minimum cover of 24 inches for 480 volts feeders encased in concrete under driveways or parking lots. The National Electrical Contractors Association, or NECA, is a leading organization that provides guidance and recommendations for electrical installations. NECA recommends a minimum cover of 24 inches for 480 volts feeders in concrete encased polyvinyl chloride conduit under driveways or parking lots, based on industry best practices and field experience. This recommendation is intended to provide adequate protection against physical damage and ensure the long-term reliability of the electrical system. When installing electrical conduit under driveways or parking lots, it's essential to follow these steps to ensure a safe and compliant installation. Firstly, obtain the necessary permits and approvals from the local authorities. Secondly, excavate a trench that is deep enough to accommodate the raceway and the required cover depth. Thirdly, install the raceway in the trench and ensure that it is properly supported and secured. Fourthly, encase the raceway in concrete if required, and ensure that the concrete is properly cured. Fifthly, backfill the trench with suitable material and compact the soil to prevent settling. Sixthly, install warning tape or markers to indicate the presence of underground electrical cables. Seventhly, conduct a thorough inspection of the installation to ensure that it meets all applicable codes and standards. Finally, document the installation and maintain accurate records for future reference. By following these steps and adhering to the National Electrical Code requirements and industry standards, you can ensure a safe and reliable electrical installation under driveways and parking lots. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It's updated every 3 years by the National Fire Protection Association, or NFPA, and it covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is not a law itself, but it's widely adopted by state and local jurisdictions as the basis for their electrical codes. Compliance with the NEC is essential for ensuring the safety of people and property from electrical hazards. Table 300.5 of the NEC specifies the minimum cover requirements for underground electrical raceways based on the voltage level and the type of raceway. The table provides different cover depths for various types of raceways, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, rigid polyvinyl chloride conduit, and reinforced thermosetting resin conduit. The cover depth is the distance between the top of the raceway and the surface of the ground. The NEC requires greater cover depths for higher voltage systems to provide adequate protection against electrical shock and other hazards. For example, the minimum cover depth for a 600 volt system is greater than the minimum cover depth for a 120 volt system. The NEC also provides exceptions to the minimum cover requirements in certain situations. For example, the NEC allows for a reduction in cover depth when the raceway is encased in concrete or when it is installed under a building. However, these exceptions are subject to specific conditions and limitations. It's important to consult the NEC carefully to determine the applicable requirements for a particular installation. In addition to Table 300.5, the NEC also contains other provisions that relate to the installation of underground electrical raceways. These provisions cover topics such as the selection of raceway materials, the installation of grounding electrodes, and the protection of raceways from physical damage. The NEC requires that underground electrical raceways be installed in a manner that protects them from physical damage, corrosion, and other hazards. The NEC also requires that underground electrical raceways be properly grounded to prevent electrical shock hazards. The NEC specifies the types of grounding electrodes that are permitted for use in underground electrical systems, as well as the methods for connecting the grounding electrodes to the raceway. The NEC also requires that underground electrical raceways be marked with warning tape or other suitable means to indicate the presence of underground electrical cables. This is to prevent accidental damage to the cables during excavation or other activities. The National Electrical Contractors Association, or NECA, is a trade association that represents electrical contractors in the United States. NECA provides a wide range of services to its members, including education, training, advocacy, and technical support. NECA also develops and publishes standards and guidelines for electrical installations. NECA's standards and guidelines are based on industry best practices and are widely recognized as authoritative sources of information on electrical installations. NECA's recommended practice for underground electrical installations provides detailed guidance on the selection of raceway materials, the installation of raceways, and the protection of raceways from physical damage. NECA's recommended practice also covers topics such as trenching, backfilling, and compaction. NECA's recommended practice is a valuable resource for electrical contractors who are involved in the installation of underground electrical raceways. In addition to the NEC and NECA's recommended practice, there are also other industry standards and guidelines that may be relevant to the installation of underground electrical raceways. These standards and guidelines cover topics such as the selection of cable types, the installation of cable splices, and the testing of electrical systems. It's important to be familiar with these standards and guidelines to ensure that the electrical installation meets all applicable requirements. When installing underground electrical raceways, it's important to take into account the specific conditions at the site. These conditions may include the soil type, the presence of groundwater, and the potential for frost heave. The soil type can affect the ability of the soil to support the raceway and can also affect the rate of corrosion of the raceway. The presence of groundwater can increase the risk of corrosion and can also make it more difficult to install the raceway. The potential for frost heave can cause the raceway to move and can damage the raceway or the cables inside. To mitigate these risks, it's important to select the appropriate raceway materials to install the raceway in a manner that protects it from corrosion and to provide adequate drainage to prevent the accumulation of groundwater. It's also important to compact the soil properly to prevent settling and to protect the raceway from frost heave. When installing underground electrical raceways under driveways or parking lots, it's important to take into account the potential for heavy traffic and the risk of physical damage from vehicles. To protect the raceway from physical damage, it's important to install it at a sufficient depth and to encase it in concrete or other suitable material. It's also important to install warning tape or other suitable means to indicate the presence of underground electrical cables. This is to prevent accidental damage to the cables during excavation or other activities. In summary, the installation of underground electrical raceways is a complex process that requires careful planning, attention to detail, and compliance with all applicable codes and standards. By following the guidelines in the NEC, NECA's recommended practice, and other industry standards, you can ensure that the electrical installation is safe, reliable, and compliant. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns. Always prioritize safety when working with electricity. Be sure to energize circuits before working on them, and use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, consult with a qualified electrician.